in about 5. I'm Barbara Knox, and I have with me today
Emily DeVizio.
Today we're going to be discussing hundreds, tens, and ones, that idea of place value. Before we get started, we'd like you to complete a task. On the next slide, you'll see the task and a QR code. We would like you to pause this video, complete the task. You can do it on your own, you can do it with a partner or even your whole team. But as you're working through the task, we want you to reflect on why it's important for students to be able to think flexibly about numbers. Here is your task, the Candio shop, and the QR code will take you there, or the bit.ly is down on the bottom of the screen if you can't get the QR code to work. We'll see you back in a few minutes. We will be referring back to that task a little bit later in this presentation. So our progression with BEST, you can see second grade is circled in the middle of the screen. Where did they come from and where are they going, Emily?
You know, as you're talking about this, I was looking and noticed that they really need to focus on those numbers and number sense and thinking flexibly about numbers to support them in second and even third and fourth grade. But I also noticed that what's new to first grade that was not with our math standards is composing and decomposing two-digit numbers in multiple ways.
Yeah, and I see that in first, second, and in third grade where they're going to be doing that with different place value amounts.
I definitely do think we did focus on that a little bit, but it wasn't necessarily explicit in the standards.
And this year it will be.
That's awesome.
We're going to take a look at the place value models. There are 3 different place value models. We're going to start by looking at the most concrete. Our groupable models can be put together and they can be taken apart. So when I build with snap cubes, I have individual snap cubes that make those trains of 10, but I can also take those 10 apart so that they're once again individual snap cubes.
Barbara, this makes me think of we really should not start with those pre-group models, base 10 blocks that we usually do, because they really need to see what makes a 10, what makes 100.
Right.
Definitely.
Right. And I mean the language of a 10 versus a group of 10, 10 ones.
Right.
The 10 means something different in both of those situations,
and that
right?
You have a 10 rod, right? Which is plural, but really we only have one item.
All right, the next type of model is the pre-grouped models, and pre-grouped models can't be taken apart. So this is the same physical size as the individual 10 ones. If I look at a 10 rod of base 10 blocks, it is the same physical size as 10 of those unit cubes put together, but I can't take that 10 rod apart.
I really like the bean representation you have down there on the sticks, because that makes the transition from counting out 10 physical beans to having one 10 stick.
Right. That was a groupable model until you glued it down, right? And then our most abstract model would be non-proportional materials. And these, if I look at place value discs, for example, 110 is exactly the same size as 1 So if I put 10 of those ones together, it would be a different size than the 10 disc all by itself.
Never really thought about those non-proportional models being so important to really focus working on the groupable and the pre-group models prior to using these.
Yeah, exactly. You can see some other examples. Money is non-proportional because 10 pennies is not the same size as 1 dime. In fact, a dime is smaller than a nickel, but worth more money.
Such a difficult concept.
Yes, it is. The language of place value can be very confusing for students. We're going to see some of the misconceptions that arise with that language and how grouping with hundreds, tens, and ones will actually help them overcome a lot of those misconceptions. So think about this. We have 10 ones on the left makes 1 10. In one of those, it is singular, so we have a group of 10 things. That's got plural things, right? We have 10 individual things. On the right, we have an actual 10 rod. That's one thing, but it is a 10.
I have to tell you, I referenced that earlier, but that was something that was new to me when I taught first grade. Like, it's not something you think of naturally. So
No.
it's huge and definitely creates a lot of misconceptions.
Yes, it does. One of the misconceptions is thinking about the digits, the actual value of a digit. In different places, the value is different. If I look at the number 24, that 2 isn't worth 2, it's worth 20, right?
Barbara, I'm thinking if we pulled out some place value charts as well
Yeah,
as those base 10 blocks, that would support students that are having this misconception.
And we could use even some of the groupable models with this and put our individual pieces in the ones place and our grouped models in the tens and in the hundreds
It'll
places.
also get them introduced to expanded form.
Exactly. Another misconception is that they'll reverse digits, and that happens until students really solidify the placement of the different values, the place values. So understanding what goes where, the place value mats are obviously going to help with that. The tools are going to help with that.
That's what I was wondering. I'm wondering if I actually had the students build 63 with their base 10 blocks and then build 36 with their base 10 blocks and then match the number to the representation.
Where you could see what did I represent with 6 things and
Right.
what did I represent with 3 things.
And what is the value of that digit?
Exactly. Yeah. Many students will put the word "and" in a number when they say it. I know when I first started teaching, I did that as an adult, so that was a habit that I had to break myself of in our number system. We use the word "and" when there's a decimal point, but we do not use the word "and" in the middle of place values. So this
really be cautious with that precision of language.
This number you see on the screen is 461. I've even listened to people on the radio just trying to find people making mistakes with that.
In the real world,
Yes,
everywhere.
Yes. When we get into the reading of numbers and having them write the standard form of that number, they do kind of an expanded number writing. It's not really expanded form, but they hear 400, so they write 400 because they heard 400. They hear 60 and they write 60, and they hear 1 and write 1. So when they end up with a 6-digit number, they don't understand that those digits 4, 6, and 1 actually represent different place values than what they intended.
Again, bringing out that place value mat and those base 10 blocks will support this misconception.
So if we have 3 place values, we should have 3 digits in our number.
Very important to point out.
And understanding where the zeros go. I mean, if I have a number with 0 tens, I have to represent that
100%,
with a 0, right?
Yes.
Exactly.
And use that language that we have 0 ones or 0 tens or whatever that 0 is in the place of.
Sometimes they'll ignore the 0. So if I have 207, they'll write a 2 and a 7 because those are the physical digit numbers that they hear, but they don't know how to write it in the place values that it belongs.
I know I keep saying it, but definitely bringing those base 10 blocks out with the place value charts will support this. Seems to be a common trend.
And if we look at those numbers at the bottom, they'll think that those all represent the same number because they have a 2 and a 7 inside it. If they're given a value of numbers out of order, they sometimes write those digits left to right. So if I give them the expanded form, I have 4 tens, 800s, 6 ones, they're going to write 486 because that's the order you set it in.
And that's the numbers I heard.
So we have to, again, get out the 10 rods. If I have 4 10 rods, then I'm going to get those out. If I have 800s flats, I'm going to get out those flats. And when I have those blocks sitting in front of me, or even put them on the place value chart, I can see that the value is actually 846. Misconception they have, and this one relates right back to that task that you did at the beginning of this session. They will think that 3-digit numbers must be made up with 3 digits, and that those single digits are all that can represent how many hundreds, tens, and ones we have in that number.
Barbara, I'm wondering, why do we have to teach them to think about numbers flexibly? I mean, in the real world, I'm going to see 846 as 846.
Right, but what if I was subtracting 90 from 846? How would I do that if I didn't know how to flexibly think about numbers? I need to be able to regroup one of those hundreds for 10 tens so that I then have 7 hundreds, 14 tens, and 6 ones.
That makes sense. And to use that language when you're actually doing that, I know we'll talk about that in a later unit.
Yes.
But it's also important for them to see that I'm not changing the value of that number. I'm just representing that number differently.
And counting after I've regrouped is going to be a helpful tool for them to understand that I still have the same value. I just have a different representation, but that representation is equivalent to 846. I can count 100, 200, 300, 400, 500, 600, 700, 710, 720, and so on, until I get to that value of 846 with those 700s, 14 tens, and 6 ones.
That makes sense. I think it's also important to point out that this connects back to the first task that we did.
Yes, it does.
And would definitely support students' misconception with this idea.
If they have experiences with tasks like that, with the tools, they should be able to handle the regrouping with equivalent representations. Here you see the concrete tools that might be used, the representations that students will make when drawing models, and the abstract thinking, which are those numbers and symbols that we put down on paper. And you want to make sure that you're making connections. So when they're building with the base 10 blocks, they should also be making quick pictures of what that looks like so that they can make the connection between the two.
And become more efficient with
Yes.
solving the problem if they don't have the manipulatives in front of
Right.
them. I also think it's important to point out that I may have to go back and forth through each of these islands
I might.
based upon my understanding with place value as a student. And that's okay.
And sometimes, I mean, I can be really solid maybe with the the numbers themselves, and I can break apart 257 into 200 plus 50 plus 7. But then when I start adding, I need to go back to that concrete island because I'm not quite sure how to do the regrouping without those tools.
But having that experience with representing numbers flexibly will support my understanding with that.
Thank you for joining us. We look forward to seeing you next time at Math Dive in about 5.
Have a great day.